Okay, so we are going to continue on the notes for negative and zero exponents. What I'm going to do is I'm just going to do a quick review, right? In the pink, we had zero, the exponent being zero, and I want you to see that it always equals one. Why? Because it's going to be the number, right, divided by itself. So you can see that it's going to be 2 divided by 2, 10 divided by 10, and x divided by x, which always equals 1. Now, I want to make you notice something else as well. I want you to look at this right here, right? So this and this, okay? And hopefully you're able to see that these two are very similar as well. And that's what we talked about with the negative exponent. What happens is it turns into a fraction, right? So it flips the base, or it's also known as reciprocal, and it goes to the bottom of the fraction. So it goes from 8 to 1 over 8, okay? So we went over what happens when you have a zero exponent. The answer is always going to be 1. Why? Because you're dividing the same number by itself. And then when you have negative exponents, what do? It makes it a fraction, right? So here are some practice examples that we're going to do together, okay? J says x to the third power, so I'm actually going to write that out. X times x times x times, right? Now, x to the negative fifth is the same thing as 1 over x to the fifth. And we could rewrite that, right, as x times x times x over 1 times 1 over x times x times x times x times x. And that's the same thing as x times x times x over 1, 2, 3, 4, 5. And then we can create our ones here. Okay, make this smaller. 1, 2, 3. And our answer here is 1 over x squared. Okie dokie. So we could say either 1 over x squared or x to the negative second power. So these will both be the same exact thing. Okay. The next problem we have is k to the fifth. Let me just move this over really quick. Okay. Oh, sorry. X to the fifth, right? So that's 1, 2, 3, 4, 5 times 6 over x to the fourth. Right, because it flipped, right? We're going to bring that over 1. We can multiply, so it's going to be 6, 1, 2, 3, 4, 5 over 1, 2, 3, 4. Create our ones, and we go 1, 2, 3, 4. And our answer here is 6x. Okay, okay. So, here's our last problem that we're going to do for this first page, and then we're going to move on to the second. Notice here that it says 4x to the negative third. Now, what's the base? Oh, it froze on me. Oh, you can see at the bottom. Oh, there you go. It was glitchy. So, right here, I want you to notice that the x is the base of this negative exponent. So we have 4. And the x to the negative third, we're going to bring that to the bottom, x to the third, times 6x to the fourth over 1. Okay, so this is 4 times 6 is 24. And then 1, 2, 3, 4 x's over 1, 2, 3 x. Where did I get this? Right there. Where did I get these 4 x's? Right there. Okay, and what I'm going to do is I'm going to create my ones. And I'm going to end up with 24x as my final answer. Okay? All right, so those are the problems, just to kind of refresh what we talked about and apply what we're doing. Now, what I'm going to do is I'm going to be telling you a story, so let's go ahead and scroll down here. And when we're dividing with negative exponents, okay, I want you to think of this to help you learn negative exponents. So let's take a look. Let's read it. So it says, and I'm just going to read from up here, the story of the two-story movie theater. So there is a special movie theater that shows amazing math movies, like Mr. Takaya recites 100 digits of pi, and kids who can't draw straight lines using rulers. I love that one, right? And the rest of your favorites. Now, there are two theaters, and they're stacked on top of each other like this. So I want you to be looking here. Here's the first theater, and here's the second theater, okay? So there's two different theaters. Now, everyone gets to go to one show, in the top theater or in the bottom theater. However, some students will receive a special pass that allows them to change theaters partway through the show so that they can see both movies. The special pass looks like this. The negative exponent that x has. So right here, this is the special pass. I want you to highlight this. This is the special pass. So go ahead and make sure you highlight that special pass. What is it? The negative exponent. Now, so when people use this pass, it changes levels, right? And they won't have the pass, and they do not have the pass anymore. So imagine this theater full of these people. 24 x squared, y to the fourth, z to the sixth, right? And that's all over 9x to the fifth, y to the negative third. Right there is, they have the special ticket, and z to the third. So what I'm going to do is I'm going to highlight our friend who has the special ticket. Why does this one right here have a special ticket? Well, this one right here has a special ticket because it has a what? Negative exponent. Okay? So right here, this negative exponent tells us that they have the special pass. Okay? And what's going to happen is they're going to be able to change levels. Remember how we talked about that? That there are two different levels on the top and on the bottom. And when you have a negative exponent, you can change levels. You could go to the top. Or if you're already at the top, you could come to the bottom. So here, I'm going to rewrite this, but we're going to let y use the ticket and come up to the top. So, right here, 24 x squared, y to the fourth, z to the sixth, and what comes up to the top? Y to the third. And look, what happened? This negative exponent is now gone. They used the ticket and now it's up to the top. Okay? And that's all over 9x to the fifth, z to the second. Notice that I did not write the y to the negative third. That moved up. We used the ticket and it's no longer at the bottom. So what it did is it flipped over to the top, that negative exponent. So now we have a expression right here. This is a number sentence, and it doesn't have any negative exponents. We got rid of it. What I'm going to do now is I'm going to expand it and then create my ones. So let's do it. On the top, we have 24. Now, 24, I'm trying to think, how can I break that down? 3 times 8. Why do I want 3 times 8? Because at the bottom, there's a 9. And I'm trying to see what common factor do they both have. And I know that they both have 3, right? And I can't, there's no common factor between 8 and 3. So 8 times 3, 3 times 8, times xx, y, 1, 2, 3, 4, 5, 6, 6 z's, and then we still have our 3 y's, right? Where did those 3 y's come from? They came from the bottom. That's this portion right here. I'll change the color just so that you understand. This is the orange one, okay? So what happened is it came up to the top. And the rest is going to be 1, 2, 3, 4, 5. Or did I get that right here? Right? And then z, 2 z's. I'm going to create my ones. Zooming in, highlight in red for my ones. Here's 1, 2, 3, 4, 5 ones. Okay? And I'm going to rewrite this now. The final answer is 8y to the 1, 2, 3, 4, 5, 6, 7. So there's 7 y's on the top. And 1, 2, 3, 4 z's. Z to the fourth over 3x there's 1, 2, 3, so 3x to the third. That is going to be my final answer. And what I had to do was I had to flip the negative exponent up to the top. Okay? Oh, so, just trying to get rid of all these little dots. Okay? So, who gets to change theaters at the end of the day? We know that y to the negative third changed theaters. Okay? That became, that's supposed to be an arrow, y to the third. And it went up to the top. Okay? All right. So here are some practice problems, just in case you need to see more examples. I'm going to highlight, right? Our special ticket holder is Z here. So Z is going to move up to the top. Okay? We're going to move that up to the top. So let's rewrite this. 6x to the 6th, z to the 5th, and now we have z to the 2nd power, and that came up all over 14x to the 5th. Now I'm going to look, what number can 16 and 14, what do they both have in common? Or I could break it up like I did before. 6 is 3 and 2, 14 is 7 and 2, and we know that they're both going to have 2's, so we're going to reduce by 2. So 6 I'm going to write as 2 times, 6 is going to be 3 times 2, 1, 2, 3, 4, 5, 6 x's, 1, 2, 3, 4, 5 z's, and another 2 z's. And those 2 z's, right here at the end, are the ones that came up to the top. Okay? And then we have 14, that's 7 times 2, and 1, 2, 3, 4, 5 x's. Create my ones. 1, 2, 3, 4, 5. And my final answer here is, let's zoom in, 3z to the 1, 2, 3, 4, 5, 6, 7 over 7. Okay? That's my final answer. 3x, I forgot an x. This x right here. I forgot to include this x right here. So that's my final answer. Okay? So the next one, 24. We have a negative exponent here. So we need to make sure that we let them use their special ticket to go to the bottom theater. So we're going to say you could come down, but you have to use your ticket, which is the negative exponent. We have 24, y to the 4th on the top, and at the bottom we have 8x to the 5th, y to the 3rd, and now we have x to the 5th also. Okay. I'm going to expand. It's going to be 8 times 3, y, over 8, 1, 2, 3, 4, 5, 1, 2, 3, and then another 1, 2, 3, 4, 5. And now I'm going to just start using my exponent rules that you guys have already learned. I'm going to create my ones really quick. And there's 1, 2, 3, which leaves us with 1y. So 3y on top. And at the bottom we had 5 in the beginning, and then another 5 added, so it's 5 to the 10th. Okay, that's going to be our answer here. Feel free to pause, go back whenever you need to. Okay. Whew, this is a big one. Now, look, there are 2 guys that have tickets. X to the negative 1. And can you find the other one? The other one with the negative exponent? Can you go ahead and highlight it right now? Okay. It is y to the negative 2nd. So here we have 2 tickets. So that means that both of these variables need to go up to the top. Okay. So I'm going to rewrite it with our negative exponent now gone. negative 16, x to the fourth, y to the fourth, z to the second. Let's draw a longer line. And what came up? X to the first, y to the second. And at the bottom, we have 32z to the second. That made it a little bit easier. Okay, let's go ahead and expand. Now, 16 goes into 32, so that's a common factor. So I'm going to do negative 1 times 16. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. And then, oh, whoa, what happened? Zoom back in. And then we have 1x and then 2y's. Okay? And just so you know, those are what was at the bottom and it came up. And then we have 2 times 16. Let me just break that up. 16 is 16 and 1. 32 is 16 times 2. I'm trying to find the two common numbers, okay? So that I could reduce. And then we have 2 z's. Z, create our ones. Bye-bye, bye-bye. And our final answer is going to be negative x to the 1, 2, 3, here. 1, 2, 3, 4, 5. And then y to the 1, 2, 3, 4, 5, 6. Y to the 6th. And at the bottom we have 2. That's our final answer. And last but not least, we have one more example. Let me just move this over so it's not in the way. Oops. All right, let's do it. Let's find our negative exponents. We have x to the negative fourth and y to the negative third. Those two will move up and down. They're going to kind of switch spots if you think of it like that. That's fine. Okay, so this is going to come up and this is going to come down. Think of the movie theaters, right? It's moving from the top or the bottom. So I'm going to rewrite it. 45 y z to the third, and what came up was y to the third. Okay, and at the bottom we have negative 36 x squared, y is gone, z to the second, and what came down? X to the fourth. Okay, now I'm going to start thinking 45 and 36. If you don't know off the top of your head, I know that 9 goes into both, but I'll just break it down. 45, 36. It's going to be 9 times 5, 30 times 3. Here we'll go 4 times 9, 2 times 2, 3 times 3. So 45, I could write it as 5 times 3 times 3, right? And then 36, I could write 2 times 2 times 3 times 3. Okay. And then we have y, z, 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 y, y, y. We have x, x, z, z, x, 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 x. Let's create our ones. 3 and 3. And z and z. On the top we have 5 y to the 1, 2, 3, 4 z over 2 times 2 is 4 x to the 1, 2, 3, 4, 5, 6. Okay. So here are day 2's notes. Okay. Your homework is right here, and all you need to do is expand. So find your negative exponents and bring them to the bottom. I highly recommend that you first find your negative exponents. Find the ones that have the ticket, okay, and move them down. So it's over 1, so it's going to, let's just do this first one. So this is m to the fourth, right, times 2 over m to the third. And then you could say this is 1, 2, 3, 4, 2 over 1, 2, 3. Create your ones. Oh, that wasn't a good one. And our answer here is 2m. Okay? So you can, once you know your rules, you're just moving things around. Negative exponents, bring it to the bottom or to the top. 0, right? If there are any zeros, this right here, I'll highlight in red. What does this equal right here? Hopefully you recognize that this is 1. So 4 times 1 to the fourth. What's 4 times 1? 4 times 1, that's all raised to the fourth. 4 times 1 equals 4 to the fourth. And there you could use your calculator. 4 to the fourth power is 256. So our answer here is 256. Okay, make sure you're checking your answers at the bottom. 256, and our other answer was 2m. Where's our 2m? Okay, check your answers. If you have any questions, make sure you ask. Save them if you want to ask me in person, and I'll love to answer them. Okay, all right, bye.